Okay, it's gonna continue. Nice explanation, right? Okay, so here is the Word document that I prepared, right? So summarize what we talked. I guess it's a good idea to update my whiteboard, right? Uh, at the end of the lecture, I'm going to update that as well. Was a nice whiteboard, right? I love it. Let me see if I'm recording. I recording. Perfect. So now let's gonna pull visual codes, right? Hmm, Visual Studio Code. Okay. Let's gonna take a look of the databases that we have here. Perfect. We're gonna take a look at Adventure World LT, right? Everyone know this is a operational database. So everything here supports daily business. Okay. So support daily business means customer products, right? Yes. We have the table customer, we have the table product, we have the table sales order, header, sales order, detail. So notice something here. What do you notice? What do you notice here? Everything is separated, right? Customers, right, are separate. Products are separate, right? Orders are separate as well. Address are separate. How do we call that? How do we call it? Normalization, right? This is what you learned in your previous course, right? Normalization. So why normalize? We need to normalize? You learned that. Remember that. Avoid duplicated data, right? Save space. Not you're gonna have a lot of tables, big table, many things, duplicated records. Yeah. Maintain consistency. I try to remember what we taught you in the previous lecture, the previous course, sorry. Correct? Basically, avoid duplicate data, save space, maintain consistency, right? Because updates are easy, right? Perfect. Normalization. Let's gonna open now data warehouse. Okay. Do these tables look different? You notice immediately, right? Okay. Professor. Pack, internet, sales, pack, internet, sales. reason, dim customer, dim date, dim product. Perfect. You notice the difference, right? So what is fact? Everything is here. Okay. What is it? A fact table store measurable business event. Typically, measure includes sales amount, order quantity, tax amount. Okay, perfect. Gonna continue here. Let me put here. What is, you can use that as your notes, right? What is a fact, right? Okay, imagine a grocery store. Okay, imagine a grocery store. Okay, s- someone buy, someone buys. Oh, that's why I don't like to type, but I want you to have this in your note. Someone buys milk, 2 gallons of milk. Okay. Now, question: what happened? This is the question here. First of all, simple question. Yeah, but it's gonna help you now. So, what happened? A sale, right? Correct? A sale. Now, that sale is called. Oops, come on. It's called a business event. Okay. Now think now about business event. Okay. Now a business event uh, become the fact. Got it? Sale, right? A sale is a business event. The business event become fact. So you can put in your note. Oh, uh, that something happen. Some examples. Okay. Sale, payment, right? Something happened. Shipment, Business event, return, reservation. No, doesn't look correct. Yeah, reservation, right? Invoice. You got it? That is the key concept. Okay. Business event. So what happened? A business event, right? See this simple example, but it's going to help you to understand the concept. Imagine a grocery store. Someone buys 2 gallons of milk. What happened? This is a sale, right? That sale is called a business event. A business event become fact. So facts, something happened. Examples, sales, payment, shipment, return, reservation, invoice. Clear for everyone, right? That is beautiful explanation. So now, let me put here. What is a store? In a fact, okay? What is a store in a fact? So fact store numbers, measurements, things we can calculate. So quantity, right? Right? What store in fact? Quantity, right? Revenue, cost, what else? Think about it. Revenue, cost, profit, discount for sure, right? Yeah, examples. What about that? Right? Clear for everyone? Notice everything is numeric quantity. Everything is numeric, right? Because we want to calculate. This is a beautiful explanation about fact. Let me put here. Okay, I'm gonna share this whiteboard with you, okay? Come on, it was a beautiful explanation, right? Mm. Yeah, I never explained like this. That's good. I like it. I'm gonna follow this format next year when I teach again this class. Okay, so sorry for the distraction. Okay, perfect. Now, Professor, but there were other tables there in the data warehouse. Dim, dim. Okay, facts are really easy now. You got it. Okay, so but where are dimensions? Okay, let's gonna explain now dimension. Dimensions. Okay. Mm, okay. Following the same example, okay? Okay. The sale happened, right? The sale happened. What else do we need to know? Okay, let me write this question. Maybe it's gonna help you to remember that. So, what else? Okay, but have to follow the example, right? Okay. Okay, let's gonna put here. The sale happened. The sale happened. Perfect. Okay. Here. What else do we need? to know. Okay. What else do we need to know? Okay. Uh, what about the customer? What about the products? What about the date? What about the store? Right? See dimension now. Uh, employee, right? Correct. We need to know about that, right? Got it? So something happening. Perfect. Don't worry. Quantity. Yes. But we need to know more information. What else? Customer, product, day, store, employee, right? This describe the sale, right? Those are dimensions. Let me put here. Describe the sale, right? Okay, perfect. So we have now fact, dimension, right? So we can write here, for example, fact, okay? Solve, right? And dimension can be who bought, right? No. Uh, what product, right? See, what else do we need to know? Dimension. Who brought? Who bought? Sorry. What product? Uh, date. When? Right? Store. Where? Beautiful. Got it? So pretend you are looking at a receipt, right? The receipt, customer, store, cashier, date, product, quantity, price, right? So which column are facts? Uh, nice example, right? Okay, a receipt, a receipt. You have the receipt, right? You have, you're looking at the receipt. You see the receipt, and you have customer, store, cashier, day, product, quantity, price. Which column are facts? Remember? Quantity, price, total, correct? Which are the dimension? Dimension are, remember? Describe the sale, right? Customer, product, store, there, date, cashier. Got it? Nice, right? So you got this concept now perfectly. Perfect. Now, there is something that is called a star scheme. You're gonna hear that in data warehouses. Star, no start, star. Why stars? Because you're gonna have here sales, and you're gonna have here date, product. Let me move here. Uh, Customer. You're gonna have here, for example, territory. Oops. Also, we can improve that, right? Sales person, right? So the center always is the fact table, okay? Everything around describe date, customer, product, sales person. This is the star scheme, okay? Star scheme, you're gonna see this concept in data warehouse a lot, okay? Sales is the fact, right? It's the center here. Everything around describe that. Perfect. So if they describe dimension, right? Got it? So let's gonna see here. Please, I recording. Please, I recording. Yes, I recording. Awesome. Where is the transactional? Perfect. Sales order header, right? Sales order detail. Many joins, right? Correct? There should be many joins. Correct? If you wanna see everything, you have to join details and header, right? And also product, you know that, many things. Now, let's gonna check the data warehouse. Let's gonna check internet sale. Oh, what? See all the columns that are there. Professor, that deserve celeb, yeah, 1,000 queries. Generating the report, just 1,000 queries, 1,000 rows. Let me close this one. Okay. You got it. It took me 3 minutes to retrieve that. Oh, see the data. How many columns you see that? Okay. The data warehouse was built specifically, right, to answer business question quickly. See that we have here. Visualize the data. We have product key, order date key, due date key, ship date, customer key, promotion key, currency key, sales territory, sales order number, sales order line number, oops, revision number, order quantity, unique price, discount amount. Wow, we have tax amount, everything calculated there. Wow, we have information that is ready to visualize, right? Instead of to compute, join with other tables, compute average, compute any mathematical operation, we have everything ready here in this table, ready to view, right? But as you see, when I retrieve the 1000, right, rows take me 3 minutes, almost 4 minutes to retrieve that information, only 1000 rows. You visualize in practice what happened? Imagine 10,000 records per second. Okay, perfect. So this is now why reporting databases exist. Okay, okay, let's gonna start running some report. Okay, uh, for AdventureWorks, you know that the AdventureWorks LT, well, you know how to run the group by, everything that we were doing. I guess I don't want to spend too much time. You know the group by, perfect. What else? We're covering a lot with the LP. Okay. However, let me think about it. Let me see the Word document. Fact table, dimensional tables. I explained that. I already covered this function, right? Let me just copy this query for the LT. It's gonna do something. I have the query here, right? Okay. So this is probably the simplest business reports ever created, right? So what we are calculating here? What we're calculating here? Revenue, right? Sum adds every order, right? One number, correct? You know, manager's log, dashboard, full of numbers like this, right? Again, I don't want to spend too much time doing that because I already covered that, but let me just copy the query that I have here for LTP. We have another query here, right? That I provide you. Perfect. So we are not longer looking at customer, right? we are counting now customers, right? Well, it doesn't have too much information, right? Order only one order per customer, right? So aggregation turn many rows into one row, but in this case, it's only one customer, one order, right? Because it's LT, right? So let me see what I have here. I guess what is gonna be now worth to explain you, even though we already do that, is that we can use derived columns, right? I mentioned that or not. Let me see. Uh, order date, perfect. And now let's gonna use year, order date as sales year. Uh, Let me run this simple query. Comma. No, no, just this one. Okay. So now we don't create new columns, right? Sales year. But remember, this is a derived column, right? So sales year column doesn't exist, right? So I will create it just for the report that is called derive derive column. Okay, just remember that. I guess a good example should be using the function year, right? So you can visualize that by year. Now let me go to Adventure Works data warehouse. Okay, this is the interesting part. So please open Adventure Works data warehouse, right? Everything we've learned so far still applies. Don't worry. Okay, we still use select, join, where, group by, order by, and aggregate function. Don't worry, we're still using the same. The SQL language hasn't changed. What has changed is the way data is organized. Okay, this is the change. Okay, in AdventureWorks LT, the database was designed to process order quickly, right? In AdventureWorks Data Warehouse, the database was designed to answer business question quickly. Okay? Business question quickly. Okay, I told you that some reports can take 30 minutes. Okay? 1 hour, 2 hours, 8 hours, 1 day. Okay. But it was faster than running that in the OLTP. In the OLTP could take longer. And also you don't have the data that we're accumulating in the data warehouse. Okay. So I guess the different what I say is correct. So in the Adventure Work LT, the database was designed to process orders quickly. Process orders. Okay. Process order quickly. Buy now, click buy now, process order quickly, right? In Adventure World Data Warehouse, the database was designed to answer business questions quickly. This is why we don't normalize too much, right? Remember the previous example, right? the amount of data that we have, the number of column, tax amount, sales amount, total price, everything is there. Information about the internet sales there. Okay. Uh, if you compare the database, you have in LT, right? In LT, you have customers, product, sales order, header, sales order detail, right? So can you immediately tell me which tables contain sales? Yes, immediately you're gonna tell me, hey, professor, it's gonna be right sales order header sales order detail, right? Immediately you're gonna tell me that, and that is correct. We have to understand the business process before writing the report. Now switch to warehouse. Okay. See, fact internet sale, dim customer, dim product, dim date, dim sales territory. Can anyone guess which table stored the sales? Internet sales, right? Exactly, right? Can anyone guess where customer information is stored? I come up, Professor, that is easy. Dim customer, right? Generating, yeah. That's gonna run, okay? Perfect, yeah, dim customer is gonna have that information. The table's name already describes their purpose. That makes reporting much easier. So we're gonna follow in that warehouse. You follow the same standard, but now you're gonna see dim fact, right? And you know what is a fact table now, fact table, dim table now, correct? So let's gonna take a look of fact internet sale now. Hey, boom! How long it take? It took me 4 minutes. 4 minutes to retrieve 10 to retrieve 1,000 rows of the customers. We have all the information for customer there. Okay, let's gonna take a look of the internet sales, right? See the number of columns, more columns that we saw in the data in the like database, right? Adventure Wars LT. So we have here product key, we have here customer key, we have here what else is important? Promotion key, sales territory key, right? We have order quantity, unit price of here in the tables sales, right? Uh, sales amount, tax amount, sales amount, tax amount, right? Rate. So this table records every internet sale. So each row, let me run again. Gonna take like 3 minutes. So each row represents one business event. This is not the same that Adventure World LT, right? You got it? So each row, each row represents one business event. That business event is a completed sale. Okay, we're gonna show in some minutes. Perfect, right? Each row represents one business event. Everything is there. So you don't need to check another table. Everything is in this table. So a complete sale is in each row. See the first column. The first column are mostly ID, right? See the last column usually mostly are numbers. So because manager want to calculate things. See here, we have here we have here numbers, right? And at the beginning, you usually see keys, right? And at the end, you're gonna see numbers: discount, product, price, cost, sales amount, tax, rates, right? See that? So, so why do you think there are so many numbers? Because manager want to calculate things like revenue, profit, quantity, taxes, rates, everything that is here. Okay, everything they need is already here. You don't have to join another table to calculate everything from this business event. Got it? Okay. Now let's gonna try to explain dimensional tables. Okay. Customer, right? Let's gonna stress my CPU. See how it's busy now? Well, let me take a look of my task manager. See how Visual Studio Code is consuming. SQL Server, right? Okay, it's done. So, okay. Do you notice when I run in the query, I was not able to expand the columns in that dim customer, right? Now it's easy because the query stopped. Stop consuming CPU, IO, right? memory. Anyway, so we have first name, last name, gender, yearly income, marital status. Yeah, just reading that, understanding the data now. Yearly income. Nice. So, sorry, I was checking the data. I distract. Okay, so question. So this table answer question about the customer, not how much they purchase, right? This table answer question about the customer. Who is the customer, right? Who is, not how much they purchase. Who they are, okay? First name, last name, where they live, right? We have that information. Education, right? Tell us about education. Income level, right? We see something about the income level, remember, right? So, these characteristics are called attributes. Attributes describe the fact, okay? So, if you open the product, okay? If you open the product, English product name, color, size, weight, product line, model name. So this table describe product, right? It does not tell us how many were sold. It simply describe them. Get it? So start opening the tables, start seeing the data, the columns, compare with Adventure Works LT. So you're going to start seeing the different design that was applied to build the data warehouse. Let me finish the query run. Okay. And now, yeah, all the information is there. Everything about the products, right? Now, something is interesting here. What is that? Okay. Dim date. Why there is a date table? Why there is a date table? Date key, full date alternative. key, the number of week. Okay, what is that? In transactional databases, we usually store a date, right? Maybe use the whiteboard in the meantime. Okay, dimensional dim, right? So what happened? In transactional databases, in TP databases, what happened? We usually store a date, right? And how is going to be the format? Well, I want to put it, I don't want to modify my setting, right? Now, in data warehouse, in data warehouse, we want much more, okay? In data warehouse, we want day, week, months, quarter, okay? Quarter. O- Okay, so here in the data warehouse, right? We want much more. We want date, week, months, quarter, quarter, year, also it's called year. Also you have quarter, physical quarter, right? Holiday, weekend, weekend, right? Okay. So instead of calculating those values every time, the data warehouse stored them once. Reporting become much faster, right? This is the idea there. Okay. Let me stop here and I'm gonna proceed with another video. Okay. With examples. Okay. Uh,